when we talked through 5.2, okay, remember when we talked through 5.2, we were given an x value and we were asked to find its z-score. You remember that? We were given an x value, and sometimes we found the probability that x would lie in the interval. And we found that by finding the area under the normal curve for that interval. Okay? But what if it were the other way around? What if we were given a probability and asked for the x value? Do you think that would be a hard thing to do? No. Okay? So some examples of stuff you might be asked. What's the lowest score you can get but still be in the top 10%? Or what's the cutoff for choosing the middle 90% of patients by their age? Okay? So let's just start off with some of these examples right here. This says find the z-score that corresponds to a cumulative area of 0.3632. Any idea on how we would do that if we're trying to find the z-score of a given area? Find the area on the chart. Okay, so let's do that. Find the area on the chart. 0.3632. 0.3632. You see it right there? So then what is it? Negative 0.35. Negative 0.35. Done. That's the z-score that corresponds to that area. Yes? What if I said find the z-score that has 10.75% of the distribution's area to its right? Well, if 10% is to its right, what are we trying to find? The other part, right? The 90, what was it, 90? Okay, so this is really the same as this, right? As a decimal. So which one are we actually looking for on the chart? 0.8925, right? So on the chart, let's find 0.8925. 89, oh, there it is. So 1.24. 1.24 is the z-score. Does that make sense? Hard or easy? Easy. Okay. Find the z-score that has 96.16 to its right. 0.9616 is on the right, so what's on the left? 0.0, oops, on the other one. 0.0384, right here. Negative 0.77. Yes? Any questions so far? Is that a no? Okay. Find the z-score for which 95% of the distribution's area lies between negative z and positive z. Huh. I still can't draw these. I'm sorry. I'm working on it. Okay. Well, if 95% lies between negative and positive, isn't it symmetric around that 0 right there? So 95% is from here to here, right? Well, if that's 95%, how much is left for the outside? 5%? Does that matter? It does, right? Because we know these two sides are also symmetric. So how much are on each side? 2.5%, right? I guess I better put percent right there. So what am I looking for right there? Looking for everything over here, right? To start with. So the number I'm actually looking for is 0.9750. Because wouldn't it be all that and all that? Or I could say 1 minus that one. But then wouldn't that still be 0.9750? Okay. So on the chart, other page, 0.9750. 1.96. 1.96. That's my z-score. Any questions? Okay. Example 2. Let's... Well, you know that it's symmetric around that 0, so you know what this is and you know what that is based on the symmetry around the 0. Because this goes almost to 2 and that goes almost to 2, just in the negative direction. So it's just asking for that z-score right there. It's not really asking for like the area. It's just saying 95% of the area. Does that make sense? Okay. All right. What if we're given a percentile? Can we find a z-score if we're given a percentile? Well, what percentile is this representing? 5%? Well, what is that as a decimal that we could look up on the standard normal distribution table? Okay, can I argue with you for just a second about that? When I look up the decimals on this table, what is true about every single one of these decimals? 4 digits. Does that matter? I don't know. Okay, but when I did all my notes, I always made sure that they were 4 because the notes that I were kind of going by were always 4. Okay? I don't think it matters as long as you realize 0.05 really is on the table 0.0500. Just to be clear and try to confuse you apparently a lot. Not on purpose. Okay? So on the table 0.0500. 0.0500. Guys, do you see it?
Wait, isn't it? Wait, 0.500, isn't that?
0.505. I got that right here. And then I got this one. Do you see it anywhere? Does that automatically mean we did something wrong? No. Okay? Think about this. Which one of these is it closer to? Oh, it's right in the middle. That brings up a whole different topic. Okay? Because, all right, let me see if I can write this down at the same time. So 0.0495, that corresponds with negative 1.65. Oh, you can't see both of those. I'm sorry. Can you just trust me on that one? It's right there. And then the other one, the 0.0505, 0.0505, that's negative 1.64. Well, if it's halfway, right halfway in between both of these values, wouldn't it make sense that my z-score is halfway in between these two? What is halfway in between those two? Yes? Do you have any questions about that? Okay. Just go with me for a second. We're going to come back to that discussion in a minute because I know you still have some more questions. I can tell by the looks on your faces. Okay? P50. The percentile of 50 percentile. That is 50%, which is 0.500. Yes. I see it twice. So it's either negative 0 or positive 0. Yeah, there's no such thing as negative 0. Yeah, you know that, right? So 0. Is there another way we could have done this question? Could have just, ignore that. Act like I didn't draw it. I'm trying to learn how to draw these things. I'm sorry. Okay? On a standard normal distribution, doesn't it go like this? Something like this? And if it's asking me the 50th percentile, isn't that right there at 0? So did I have to use the table? No, but was it okay that I did? Yeah? Okay. Okay, now let's come back to this conversation. P90. 90%. P9, okay, I'm sorry, P90x, is that better? Okay, so 0.9000, right? Okay, 0.9000, where am I looking? Well, what do we do then? We have to find like exactly halfway in the between, right? Wait, is that even possible? It's really close to these two, right? Is it exactly halfway in between these two? No. So I can't go that next step further. Okay? Which one is it closer to? This one, right? So when it says find the z-score for the given percentile, I can't really, but what I can say, 1.28, I have a couple possibilities. I can say about 1.28. I can say it's approximately equal to 1.28. Either one is okay. It will basically depend on how the question is asking you. Okay? Because if it says find the z-score that's close to the given percentile or something like that, or find the approximate z-score of the given percentile, 1.28 is perfectly fine, isn't it? Any questions about that? All right, what about this one? P10. 10%? 0.1000? Not one. Which one's closest? This one, right? Negative 1.28. Whoops. Negative 1.28. So this is interesting to me. 90% was about 1.28. 10% was about negative 1.28. Are those related? Isn't that this much on this side? This one is? Isn't that this much like on that side? So would it make sense that it's an equal distance away from the zero? One in the negative direction, one in the positive direction? Is that interesting to you, or is it just me? Yes? Okay, good. Now I don't feel so bad. What about this one? P20. 20%? 0.2000? 0.2005. I got that. Negative 0.84. Excuse me. Negative point. I keep forgetting my negatives. Okay so far? Yes or no? All right, one more. I know it looks like there's two, but I accidentally wrote that one twice. Okay, find the z-score for the given percentile, P90. Except it says 99. 99% is 0.9900. Look at our chart. 0.9901. Is that close? Is that closer than this? Which one's closer? Which one's closer of these two? The right one. This is only 1/10,000th away, and this is 2, right? So 2.33. Got it? Oh, it's approximate too, isn't it? All right. Any questions about that? You got that okay? All right. So let me remind you of something we worked on before. We said z equals x minus mu over sigma. I struggle drawing those. Please forgive me. This is when you have an x and you're asked for the z-score. right? You have an x-score and you're asked for the z-score. Could we do the same thing like we were doing a minute ago and go the other way? Could we be given a z-score and be asked for the x-score? Would this be difficult to transform so that it was the x to solve for and not just the z? Not difficult at all, right? So if I multiplied both sides by sigma, I would get z sigma equals x minus mu, and then just adding mu to both sides. So z sigma plus mu would equal x. Not difficult at all. That's just basic algebra, isn't it? Just with Greek letters instead of numbers like we're used to. Okay? So why would we need this instead of just being able to use a table like this? Well, all our problems aren't just give me a z-score if you know the percentile. Give me a z-score if you have the area or something like that, right? Sometimes the problems look like this. A vet records the weights of cats in a clinic. The weights are normally distributed with a mean of 9 and a standard deviation of 2. Find the weights of the corresponding z-scores. Well, if you know z-score is 1.96, would the weight or the x value be hard to find if you knew this formula? Not at all, right? So x is going to equal the z-score, which is 1.96, times the standard deviation of 2, plus the mean, which is 9. And that's just some calculation, right? 12.92 pounds. You okay with that? What happens if my z-score is negative 0.44? Well, x would equal the z-score times the standard deviation plus the mean. Calculation, 8.12 pounds. What if my z-score is 0? X equals 0 times 2 plus 9. You don't need me to do the calculation this time, right? 9 pounds. So here's something I want you to be aware of. I want you to notice. Okay? Positive z-score or negative z-score? Positive, above or below the mean? Positive z-score or negative z-score? Above or below the mean? Does that make sense? That's a program you can run in the background of your brain when you're doing some of these problems. Okay? No, I'm sorry, I didn't mean a literal program. I just meant some to think about in your brain. Okay? When you've got a positive z-score, your answer really ought to be above the mean. When you've got a negative z-score, your answer ought to be below the mean. Why was this one exactly the mean? Because when my z is 0, that is the mean, isn't it? Okay? So what if I was measuring dogs and not cats? So what if I had a mean of 52 pounds and a standard deviation of 15 pounds? Yeah, I just change the numbers and do the same thing, right? So x should equal the z-score, negative 2.33, times the standard deviation plus the mean. Now, here's my question. Should this answer be about 30 pounds less? A little more than 30 pounds less. Why? What's my standard deviation? 15. So when I do calculation, I get 17.05. Is that something I expected? Is that a little bit more than 30 pounds less than this? Yeah, it is, isn't it? Okay? Again, something to think about in the back of your brain when you're doing these problems. X equals 3.10 times 15 plus 52. Before we write the answer, what are you expecting? More than 52? And in fact, about 45 more than 52, right? 98.5. Did you expect that? 45 would be 97, and we said a little more than 45, right? What about if z is 0.58? What are you expecting? More than mean because it's positive. A lot more than the mean? 7 or 8 pounds more than the mean? Is that what we expected? Yes? Okay. Any questions about that so far? Scores for a test are normally distributed with a mean of 50 and a standard deviation of 10. A group wants to hire only out of the top 10%. What's the lowest score that someone can make and still be eligible to be hired? So on my picture, I need top 10%, right? This is what I need over here. But I'm trying to find the lowest score, almost like to the edge of this, right? What's the lowest score that someone can make and still be hired? So if this is 10%, what is this over here? 90%. So what am I actually looking for on my standard normal deviation table or distribution table? 0.9. That's the closest, isn't it? 1.28. So I'm going to say that right there is 1.28. Well, if that's 1.28, what is that value that I just found? That's the z, isn't it? So my x value is going to be that z value times the standard deviation, which is right there, 10%, or 10, just 10, plus the mean, which would be 62.8. So that answers the equation. So now tell me the answer to the question. What's the lowest score someone can make and still be eligible to be hired? Why is it 63 and not 62.8? It's a little less, and didn't we round? Like we had to guess on that one because there wasn't exactly 0.9, right? Also, can you really get a 62.8 on a test? I know in some people's class you can. I'm not arguing about that. I'm just saying most people, even when you put grades in the computer, we had to put in whole numbers. Okay? So that's why we want to say it. A 63 is the lowest you can score and still be eligible to be in that top 10%. Any questions about that? Okay, one more example. Ready for it? I mean, are you ready for it? Yes! Okay. Researcher tests the braking distances of several cars. Can you find my spelling error? The braking distance from 60 miles per hour to complete a stop on dry pavement is measured in feet. The braking distances of a sample of cars are normally distributed with a mean of 129 feet and a standard deviation of 5.18 feet. What is the longest braking distance one of these cars could have and still be in the bottom 1%? Did you find it, by the way? Normally? Yeah, that's a funny word. That's because it's not a real word. Okay. So here's my picture. I need the top 1%, sorry, the bottom 1%, right? So this is the part that I had to speak with Elizabeth about, okay? Because what I actually have to look up on the table is not the 1%, it's the 99%. Because I'm trying to go at it from this direction. I need the longest braking distance that a car could have and still be in the bottom 1%. Does that make sense? So if I look up 0.990 on this paper, 0.99, that's the closest one, right? 2.33. 2.33. And I think I just figured it out. Look at this. What if I looked up 0.0100? Is that what I want? If this is 99%, this is 1%, so that's 0.100, right? 0.0100, negative 2.32. Nope, that one's closer, isn't it? Negative 2.33. So 99% is the positive 2.33. The negative 2.33 comes right there. Okay, so negative 2.33 is what I'm talking about. That's that dividing line right there from the 0 in the middle. Okay, so if that is my z-score, to find x, I say negative 2.33 times 5.18, which is my standard deviation from up here, plus my mean, which is 129. Calculation, 116.93. So what's the longest braking distance one of these cars could have and still be in the bottom 1%? I did round this a little bit, so I want to go to 117 feet. Okay? Any questions about that? You good? Okay, so that's for the first part of 5.3. We're going to talk about the second part of 5.3 tomorrow, and then 5.4 the day after that. Okay?